All right, today we're going to tackle a really common coding problem, one you'll see all over the place. Contains duplicate. Now, it sounds simple, right? But digging into how to solve it efficiently, well, that tells you a lot about what makes for truly great code. So, let's get started.
So here's our roadmap. First, we'll break down the problem itself. What are we even trying to do? Then, we'll look at the most obvious solution, the brute force method, and see why it's, well, not great. From there, we'll try a smarter approach using sorting before we finally land on the gold standard solution with a hash set. And to wrap it all up, we'll make sure our best solution can handle any weird curveballs we throw at it.
Okay, first things first. Before we can even think about solving this, we need to be crystal clear on what the mission is. What does winning look like here? So think of yourself as a detective. You're handed a list of numbers, an array of integers. Your only job is to answer one simple question. Is there a duplicate in here? Does any number show up more than once? If the answer is yes, you return true. If every single number is unique, you return false. Simple as that.
So just pause for a second. Forget about fancy algorithms. If I gave you a list of numbers on a piece of paper, what's the very first, most gut instinct way you'd check for a duplicate?
That first idea you probably had, that's what we call the brute force method in the programming world. It's simple, it's direct, but oh boy, it comes with a hidden cost. The logic here is exactly what it sounds like. You pick up the first number on the list and you compare it to the second, the third, the fourth, all the way to the end. No match? Okay. Now you pick up the second number and you compare it to the third, the fourth, the fifth. You see where this is going, right? It's a ton of repeated work. And this right here shows the classic trade-off. On the one hand, it's great with memory. We're not using any extra space at all, which is awesome. But the time it takes, that's a different story. We call this O of n squared. For each of the n items in our list, we're doing almost n comparisons. For a small list, maybe you don't notice. But for a list of, say, 10,000 items, that's going to be slow. 100,000? Forget about it. It just doesn't scale. Okay, so brute force is out. It's just too slow for the real world. So how can we get smarter about this? What if we organize the numbers before we started looking? Now, this is a much more clever approach. Think about it. If you sort the array first, any duplicates will be forced to sit right next to each other. So you no longer have to compare every number to every other number. You just have to do one clean sweep through the list and ask, is this number the same as the one right next to it? So much easier. And you can see the results. Our time complexity gets a huge upgrade to O of n log n. Now, that's the typical speed for a good sorting algorithm, and trust me, it is worlds faster than n squared. We've gained a massive amount of speed, and we're still not using any extra memory. This is a big improvement. But can we do even better? To get to that next level, to find the absolute fastest solution, we have to change our strategy. Up until now, we've been really protective of our memory. But what if we made a trade? What if we used a little bit of extra space to buy ourselves a ton of speed? And that trade leads us to the best solution, which uses a really cool data structure called a hash set. Honestly, it feels like it was custom built to solve this exact problem. So what is a hash set? Think of it like a super exclusive club with a magical bouncer. Every time a number tries to get in, the bouncer doesn't have to scan a long guest list. Instead, they have this special power to instantly know if they've seen that number before. The check is instantaneous, what we call O of one time. It's either, nope, you're new, come on in, or hey, I've seen you before. It's that fast. With the hash set, our algorithm becomes beautiful and simple. We start with an empty set, our empty club. Then we go through our list of numbers one by one. For each number, we ask our bouncer, hey, is this number already in the club? If the answer is yes, boom, we're done. We found our duplicate and we can immediately return true. If the answer is no, we let the number into the club. We add it to our set and we move on to the next one. If we get all the way to the end of the list without finding a match, we know every number was unique. And here's the final scorecard. The hash set solution gets us to O of n, or linear time. This is basically the holy grail for this problem. It means the time it takes to run grows in a straight line with the size of the list. We just have to look at each item once. Now, the price for this amazing speed is O of n space, because in the worst case, we might have to store every single number in our set. But that trade-off is almost always worth it. Okay, so we've got a solution that's fast and elegant. But is it tough? A great solution has to handle all the weird stuff you can throw at it, what we call edge cases. So let's put it through a little stress test. So let's run it through the gauntlet. What if the list just has one number? It returns false. Perfect. What if it's all duplicates? It finds the match on the second number and stops. Super efficient. Negative numbers? Zeros? Absolutely gigantic numbers? The HashSet doesn't care. It handles them all flawlessly. Even a huge list with 100,000 elements gets processed in a flash. Our solution is officially rock solid. And this brings us right to the heart of the matter, the big lesson from this whole exercise. Very often, the secret to making your code dramatically faster isn't some super complex logic. It's about choosing the right tool for the job. In this case, it was being willing to use a little memory to save a whole lot of time. So, I'll leave you with this to think about. This idea of trading space for time is a fundamental concept, and it pops up everywhere. So think about your own work or other problems you've run into. Where is there a slow, clunky process that could be completely transformed just by using a simple data structure, like a hash set? It's a really powerful question to ask.